Okay, we'll take a look at the chapter 4 review here. I'm using this as a review here today. So question number 1. Again, when you read a question that doesn't have a diagram, you probably should draw a diagram whenever possible. So it does say in the instructions too, show your work and sketch a diagram where possible. So we're going to do that. Question number 1 says this. A construction company is assembling a slide in a children's playground. The slide is 8.3 meters long. If the slide can have a maximum slope of 35 degrees, how high can the top of the slide be? So here's the information. The slide itself is 8.3. So I'm going to draw the slide here. That's 8.3 meters. It can have a maximum slope of 35. So it looks like this slope, 35 degrees from what would be the horizontal. So the question says, how high can the top of the slide be? Well, that's pretty straightforward here, it looks like. We have a right triangle, and this is what we have. Very important. You look at the angle, you have an angle. You have the hypotenuse. That's the hypotenuse. And we're looking for this side. So is this the opposite side to 35 or the adjacent side to 35? What is it? Opposite. Yeah, does everyone see that? Opposite side? So this is opposite side, right? Because it's straight through the angle and hits that side. That's opposite. So what side is this we said was the... Is that adjacent or hypotenuse? Which one's that? It's opposite of the 90-degree angle there, so it's a hypotenuse. Okay? Also, what you need to remember is SOHCAHTOA, right? SOHCAHTOA. SOHCAHTOA. So which trig function has opposite, O, and hypotenuse, H? First one, right? So that is sine, right? So you set up your equation like this. Sine of the angle that we're talking about, which is 35, equals opposite divided by hypotenuse. Opposite, we don't know what it is. Hypotenuse, 8.3. Now it seems pretty easy to know what to do. We want to get opposite side here by itself, so we multiply both sides by 8.3. So the opposite side is 8.3 times sine of 35, right? So let's just do that on the calculator here. 8.3 times sine of 35. And if I am in radians, the default for this calculator is radians. So, okay, let's see. 4.7 or 4.8. Do we see that as one of the answers? Yes. Yeah. Okay. So the answer to question number 1 is 4.8. That's A. Okay. Did you get A for number 1? Yeah? Yes? Okay. Have you all done number 2? No. That didn't quite get number 2? You stuck? Okay, let's take a look at number 2 then right away here. Okay. Xavier is installing 2 sections of pipe. The first section is 5.5 meters long and makes an angle of 18 degrees below the horizontal. So here's the horizontal. 18 degrees below the horizontal would be right about here. Here's 18 below the horizontal. So it's a pipe that's going downward, looks like. And that's 5.5. Okay. The second section of pipe is attached to the end of the first with a bend. The second pipe is 4.4 meters long and makes an angle of 30 degrees below the horizontal. So it's attached to the end of the pipe and it has an angle of 30 degrees. Let's say it's somewhere around there. It's a bit much maybe, but the 18 was a bit much too. So, and it is how long? 4.4. So it's going to be a little shorter. 4.4. Okay? So we have one section of pipe like this. We have another section of pipe like this. See that? And they're at different kind of angles. What is the total drop from the start of the first pipe? So obviously these pipes are going kind of downhill, right? Or underground or whatever they're doing, maybe from the top of a building. So what's the total drop? So that means I want to know what is this right here, the total drop from the start of the first pipe to the end of the last one. And what you need to understand is that there's going to be two separate triangles here. So there's going to be this triangle that has a 90 degree because it's a straight drop down, so you can drop that down 90. And then there's going to be another triangle right here. Okay? Now what do we do with these degrees now? So remember, if you take a look here, this first triangle, I'll maybe highlight it with a highlighter here. The first triangle here. This 18 is not in the triangle, is it? So we have to figure out what angle this is. This, the horizontal to a straight down drop, is 90 degrees. So if this is 18 right here, then this other angle has got to be 90 minus 18, which is maybe 72. Okay, so there's your first triangle, and you can find this length right here. Do the same sort of thing for this other triangle. Find out what this angle is, and then find this drop right here. Then add the two together. Okay? So I'll give you a minute or two to figure out that one, because it looks like that one got some of you stuck. And then I'll show you the answer in a minute. Okay, so in the first triangle, you've got an angle, you've got the hypotenuse length. You're trying to find the adjacent side. So what is adjacent and hypotenuse? Which trig function is that? So ka toa, right? So ka toa. So it's cosine of 72 degrees equals adjacent, that's x, over hypotenuse, over 5.5. So remember, always go from your SOHCAHTOA, write out the equation with all the values you can, and then solve for the unknown one. So 5.5 times cos of 72 equals x. 5.5 times cos of 72 equals 1.69 or 1.7. Anybody else get that? For x? Yeah. Okay, so now down over here, this is 30, so this much must be 60, right? Because 60 plus 30 is 90. And this have to equal 90. So now you've got, again, hypotenuse and adjacent. So I'll change color to blue over here, and I'll do cos of 60 now equals adjacent, it's y over hypotenuse, 4.4. So 4.4 times cos 60 equals y. So y is going to be 2.2. So 1.7 plus 2.2 is going to be 3.9 meters. So your answer should be D for number 2. Okay, any questions about that one? Okay, if we take a look at number 3 says we have a cube. So remember, a cube is a three-dimensional figure where all the sides are the same length. So lengths of 9. So we've got 9 here, 9 here, and 9 here. That's a cube. A hole is drilled from one corner straight through the center and out the other side. What's the length of the hole? So it might be a little bit tough to see, but let's say we started on this far back corner and we drilled the hole right through the center of the cube, which is right about here, and then it came out the other side, so it would end up through this corner right here. Okay, so what does that mean? That could be a little bit tricky, right? So let's see. If I viewed this cube, and here's a cube right here, right? So if I viewed this cube and I said I'm going to drill from this corner all the way through the middle and out this corner down here. All right, so that's kind of what your shape looks like. Oops, there you go. Okay. So watch this. This 9 by 9, if I viewed it from the top, 9 by 9, if this was this side and this side, then the hole is going from here all the way up through this other corner up here where the other 9 is. Okay? So there's two triangles here. And this one actually is pretty tough, I think, to visualize. But if you think about this triangle first, where you have a hypotenuse here that goes right along the bottom face of the cube, that's this length right here. Then you have a second triangle over here at the cube, uses that length, and then this height. And then now you can find this whole length. So it's here, here, and here. So there's two triangles there. Okay. So there's two steps to this one too. So let's do Pythagoras' theorem to find out this one. So it's 9 squared plus 9 squared equals x squared. X equals, well, I won't skip any steps for you. So 81 plus 81 is 162. The square root of 162, square root 162 is 12.7. All right, so we're not quite done there yet, because we're actually looking for this one, that side. So we have to do another triangle here. We have to do this triangle where we have 12.7 and then up 9. Then I got to find this hypotenuse. Okay, so again, this first triangle is laying on the ground here. See, it's laying on the ground. Half of the bottom face of the cube. And then the second triangle is kind of slicing through the cube. So let's do this. Let's do 12.7 squared plus 9 squared equals, we'll say this is y. This is what our answer is going to be, y squared. So 12.7 squared is about 162 plus 81 equals y squared. Y is the square root. We take the square root of both sides. What's 162 plus 81? It's 243. The square root of 243 is 15.59. Okay, so that's a pretty tough question. We're looking at C here for an answer. C. And without that diagram, that's tricky. That's tricky. I will have some shapes available for you for your test here, up here. If you want to come and take a look at a cube or a cone or a pyramid and just look at it and feel it and touch it, that's totally fine. I'll have them up here. You can take a look at that. So this if you're looking at the cube like, how am I going to do that for you? Like this. So the first triangle we did was the half of the underside there. This one, half of the underside. Okay, half of this, so about that one, that length, and then we use that length to find the diagonal right through the corners of the cube. Okay, number 3, tricky one. All right, but you got to be ready for some of these on your test. You got to be ready for some of these on your test. All right. Number 4, let's round off this first page. Number 4 says, which of the following cannot form a right-angled triangle? Okay, and we're given side lengths here, right? So what you have to remember here is that a squared plus b squared has to equal c squared. That's Pythagoras' theorem. And c is always the largest value. So in this first one, this is c. In b, this is c, because it's always the largest value is the hypotenuse. This is c. and this is C. So you can just kind of run this through if you want. Like for example, 16. Okay, so well, I guess the other thing you could do too, and you might not recognize this right away, but in a triangle, you see. So look at this one. Look at A. Okay. If you have two sides that are 16 by 16. Okay, 16 by 16. All right. Then the third side has to be at least 32, because if you were to lay those sides at an angle of 0, right, that has to be 32 right here. Those two sides put right up together. So if you ever have a situation where the longest side is longer than the sum of the two, then you got a problem. So the maximum this third side could be is 32. So right away, 16 plus 16 is less than 34. So this cannot be a right triangle. It's not a triangle at all. Does that make sense? Let me get my pens out here. So let's say this was 16 and 16. Okay? The third side can be as small as you want. It can be as small as you want there. But it can't be any bigger than the sum of the two sides. Okay, so this is 16 and this is 16. This whole length is 32. So if you have a third side that's 34, you can't even make a triangle. Right? It would be something like this, and then this side is like way too long. You see? So not even possible. Other than that, knowing that now, other than that, you can just do, 5 squared plus 12 squared. Does that equal 13 squared? Or 17 squared plus 5 squared. Does that equal 26 squared? And you can just try these out in your calculator real quick. I maybe won't do them all, but let's just try C here, for example. So 5 squared plus 12 squared equals 169. Take the square root of that. And if it's 13, you have a winner. And it is. Okay? So you could just do that really quickly for all of them as well. So this one is C as well. So that first page looks like ADCC. How does that sound to you guys? Does that sound right? Sorry? Which of these cannot? Sorry, you're right. A, which of these cannot? So I guess if you tried these other ones, they would work. Yeah, sorry, I kind of got backwards there. So A is the one that cannot form a right triangle. And if you tried, sorry, you're right, this is A. If you tried 16 squared plus 16 squared, it would not equal 34 squared. Yeah, I kind of got myself backed around there. So C and D and B, they should all work with Pythagoras. So any that doesn't work is the one you're looking for. Sorry, A, D, C, A, correct. Good. Anything else about that one that we need to talk about? All right. If you haven't started on the short answer yet, go ahead and start on the short answer, and we'll take a look at those next.